Hello, Digital 2. This is Professor Late. Today we're going to be going over lab number 4, the digital analog converter, or the DAC. Step number 1 tells us to turn the trainer power off and construct the circuit shown below, making sure to connect the multimeter in series between the potentiometer and the positive 5 voltage reference source. So here's the circuit, and you can see that we have our multimeter hooked in between our positive 5 volt reference and our potentiometer. We're going to set our multimeter to the milliamp range. Next, we're going to turn on our trainer and then adjust so that we get 2 milliamps coming through our potentiometer. So to adjust, what we're going to do is just turn the potentiometer until we read 2 milliamps. Go back a little. Too far. And there we have approximately 2 milliamps. 1.998 milliamps, I'll call that 2. Next, it tells us to turn the power off and remove the multimeter from between the potentiometer and the 5 volts. Then we're going to connect the black lead to the I out line, which is pin 4, and the red lead is to ground. Next, we're going to turn the trainer back on and make sure that all of our switches are down to 0. And we're going to take a look at our multimeter to see that we have 0 current coming out. Next, we're going to go down to table 1. So normally what we would have done is we would have had you choose your values in between the values given. However, since that's not possible, since you're watching this from home, I've gone ahead and put in the values that we are going to use. So you might want to pause the video now and copy down that first column of table 1. The next thing you're going to want to look at is this formula here. That's how we're going to calculate our current out. So to do the first row where it's all zeros, we're going to multiply our 2 milliamp reference with 0. And that gives us a calculated current out of 0. So with all our switches set to 0, we calculated a current out of 0. And our measurement validates that. We're at 0 milliamps. So to calculate our next value, we're going to need to use our calculator. So we see that we have the 3 and the 4 switch turned to 1. With the 3 and the 4 switch turned to 1, that means we are going to add 1/16. So 1 divided by, let me turn that on. 1 divided by 16 plus our third switch, our 3 switch of 1 divided by 32. That gives us 93 milli. We're going to multiply that by our 2 milli reference. So times 2 shift M equals, so we have a calculated current out of 187.5 micro. So when we turn on switches 3 and 4, you see that we get a reading of 0.186 milliamps, or in other words, 187 microamps. So that's pretty close to what we calculated it to be. So we'll do the next one together. So breaking out our calculators, we're going to have to add switch 2 and switch 5. So switch 5 is 1/8, so 1 divided by 8 plus switch 2, which is 1 divided by 64 equals, and then we're going to multiply that by our reference of 2 milliamps. Oh, hold on. Let's try that again. Punch those in, Ron. So 1 divided by 8 plus 1 divided by 64 equals times 2 shift milli equals. We end up with 281.25 microamps. That's our calculated value. So you can see with switches 2 and 5 on, only those two, our current output is 0.279 milliamps. So in other words, 279 microamps. So once again, that's really close to what we calculated. So at this time, I want you to go ahead, pause the video, and calculate out the rest of the column. So your I out calculated, you should complete that now. Then once you resume the video, I'll go over the measured current out for each of them. All right, so for 0, 1, 1, 0, 0, 1, 1, 0. So in other words, switches 1, 2, 5, and 6 are on. We have a measured value of 794 microamps. For 1, 0, 0, 0, 0, 0, 0, 0. So in other words, switch 7 is on and the rest are off. We get 0.995 milliamps. So we could round that up to 1 milliamp. So for 1, 0, 0, 0, 1, 0, 0, 0, so switch 3 and switch 7 on, we have 1.058 milliamps. For 1, 0, 1, 0, 1, 0, 1, 0. So switches 1, 3, 5, and 7 are on. We get a reading of 1.322 milliamps. So for 1, 1, 0, 0, 1, 1, 0, 0, so switches 2, 3, 6, and 7 on, we have a reading of 1.59 milliamps. For 1, 1, 0, 1, 1, 0, 1, 1, switches 0, 1, 3, 4, 6, and 7 on, we have a reading of 1.707 milliamps. For 1, 1, 1, 0, 0, 1, 1, 1, we have a reading of 1.8 milliamps. And for all ones, all our switches 0 through 7 are on, we get a reading of 1.988 milliamps. Moving on to part 15. Part 15 tells us to connect this op-amp circuit to our current out. So I've added this op-amp circuit into our current out. We're going to use this new circuit to fill out table 2. Normally, you would use your own values, but since you don't have that option, once again, I've pre-filled this out for you. So go ahead and pause the video and write down the input values in this first column. So we're going to use this formula to figure out our calculated values of our volts out. So let's do a few of them together. So for the first row where it's all zeros, our voltage out calculated is going to be our reference of 2 milli times our resistor value of 4.7K times 0, because all of our switches are at 0. So whenever you multiply anything by 0, you get 0. So that first row should be a volt out calculated of 0. And you can see when we measure that value, we are at 1.2 or 1.1 millivolts, which is pretty much 0. That's just ambient voltage that's around us all the time. So to calculate the next row of 0, 0, 0, 0, 1, 0, 0, we're going to use the calculator and put in our formula. So we're going to use, since it's switch number 3, we're going to have 1 divided by 32 equals, we're going to multiply that by our 2 milli reference, and then we're going to multiply it also by 4.7 kiloohms, and we end up with a value of 239.75 milli. So that's 293.75 millivolts. All right, so we have 1 divided by 16 equals times 0.002 for our 2 milli times 4,700 for our 4.7K. And we end up with 587.5 milli, and that's millivolts. So when we have our circuit with our switches for only the 4 is on, we get a reading of 582.7 millivolts, which once again is pretty close to what we calculated it to be. So let's go through the rest of this table. So we're now at 001, 00000. And you can see that we have a measured value of 1.159 volts. Okay, if you haven't already done so, go through and do the calculations for the rest of the table. For 1,000,000, we get a reading of 4.626 volts. For 1,000,000, we get a reading of 4.772 volts. For 1,000,000, we get a reading of 4.915 volts. For 1,000,000, we have a reading of 5.208 volts. For 1,010,000, we have a reading of 5.785 volts. For 1,1,0,0,0,0, we have a reading of 6.944 volts. And for all ones, we have a reading of 9.227 volts. So you should have found that our measured voltages were pretty close to what we calculated the voltages to be. So that concludes lab number 4. Make sure you write up your conclusion for this lab and compile it with the rest of the labs into your lab portfolio. You should have 4 labs. Make sure you have your header page and your table of contents. This has been Professor Late. I enjoyed having you, well, sort of having you in class, or at least just watching these videos. I hope your summer is great. Bye.